and welcome to my talk. My name is Johannes Schindelin. I am the maintainer of Git for Windows, and I work at Microsoft. If you would have told me that I would work at Microsoft 10 years ago, I would have died laughing. It's been quite a ride. The world has changed over the course of the last 10 years. Of course, most dramatically in the last few months. That's why we have a virtual conference now. So let me first start by introducing Git a little bit more, like the idea of Git for everyone. What is Git? What is Git if it's for everyone? So Git is a version control system. Version control system means that you have a set of files that belong together and you make new revisions every once in a while. So typically, every once in a while means even multiple times a day. So that's definitely more than a version of a full project. Most often, Git is used to version control source code files. That's why it's also often called a source code management tool. I myself not only use it for source code though. So I collaborated with scientists on scientific articles. In my previous job, I was a scientist, and I wrote files. I wrote things in LaTeX, which is it's a markup language. So, in a sense, it is source code, but the output is not a program that runs. The output is a beautiful typeset article. And I collaborated with people who were on different continents. And I was writing my things, and they were writing their things. I was modifying their things, and they were modifying mine. And we were reconciling each other's changes. And that's basically what version control is about. That's what Git facilitates. But as Git is for everyone, or at least my intention is to make it possible for everyone to use Git. That's why I maintain Git for Windows. Let me first introduce a couple of concepts. So in order to show you the concepts, I would like to show you this website. It's training material of GitHub. It's try.github.io. There are plenty of other resources. It's just that I like these resources particular. And first, I would like to go to the visualizing Git part, because when you use Git, you kind of need a mental model of what you're doing there in the background so that you understand what's going to happen. So each revision of files is called a commit, and that's because the command to make a new revision in Git is called git commit. So there was already a first commit here in this example, and I'll just add another one. And let's keep with the sample of the scientific articles, because it was actually a fun time there. So let's assume that I wrote the first chapter. So I would say first chapter. So here I just said git commit with -m, means that's the message that I want to provide with a change. And here you see it, first chapter. Of course, the commit message that you give should usually be a little bit more useful. It should say something about what is this change about? Why is it good to have it? But for the moment, I'll just stay here because with the short names, because that's not the main purpose of this illustration. It's that we can write the first chapter, and then I can add more figures, add figures. And now let's say that my colleague Jane wants to collaborate with me, and actually I gave them access to my code yesterday. So yesterday I wrote the first chapter, and they just got that part. So they kind of branched off. They started their own development. So let's simulate that here. I make a new branch called Jane, and that's coming from this funny thing here. That funny thing, that is the internal name of the commit. And it's basically, it identifies the commit and its entire history, including all the contents. Let's see here. Okay, so Jane started yesterday, and I actually found a couple of typos because I'm not a native speaker, so let's fix some typos. Fix typos. See, I'm not good at typing. Okay, but now, of course, after that fix, Jane wants to reconcile with my changes, and I added some figures, so Jane would merge here, my branch. By the way, the branch is called master for historical reasons. It's not a good name. In the meantime, it has been very clear that this is fraught with bad moments in history. A much better name to think of would be default, because that's the default branch. It's the first branch that Git wants to make. Maybe at some stage we'll manage to change this, but Git is 15 years old. After 15 years, it's hard to change things like this. For the purpose of my talk, this is what I wanted to show you, the entire commit graph. So there are revisions that have multiple parents. Most revisions have only one parent. And so you have revision one after the other. You have a collaboration where people start to diverge and then reconcile their changes. And that's really the essence of Git. Now, with what I wrote here, of course, you're missing part of it because I only wrote the Git commands. I did not provide the content. I did not modify anything. So I could show you this here. So just git init, initialize a new Git repository. Of course, I had already initialized it, so it says now reinitialize. I already have a file here that's called hello.md. Let's see the contents. Now I could just add it here, right? And I could commit it. But as my talk is about Git for everyone, I cannot fail to see that this is very, very much command line, right? And command line is, some people will probably run away kicking and screaming if I tell them, you just got to use the command line. So in order to make this better for them, there are user interfaces that are graphical. So I would like to show you one of them. That's GitHub Desktop. There are many more, and you can pick and choose whatever you like. Here you see essentially the same view as I showed you. It's here, this is the new file. It's called hello.md. I know I can say this is first commit. I could say first commit, but I want to say something a little bit more meaningful, really. A demo for open source universal submit. So this is the first demo commit, adding a file that just demonstrates, too many demos here, huh? Demonstrates how to commit files. Okay, let's commit it. Done. Now I could take this and publish this to any number of Git hosters, for example, GitHub or GitLab or Bitbucket, and then other people could get my changes or get my repository and start making their changes, then contribute them back. And that's the collaboration. That's all what Git is all about. So let's go back to here, because now that I showed you how you can use this, I want to show you that many people really use this, not only for source code. For example, here is a talk that was given at a Git merge by some person developing games. And if you think about games, yeah, there is a component that's source code, but that's actually a tiny part. It's not even the most important part. The most important part is the graphics and the music. That's the layouts of multi-worlds or something. And so they have their own challenges, because if you want to reconcile changes, for example, between two images or two 3D models, it's not quite clear how you would do that. It's much easier with source code because it has been done such a lot. But Git is extensible and allows even for that. So if you merge something and the something is not a source code, you can provide a merge tool to help reconcile diverging developments. Another use case, of course, is to just kind of build a diary. And in this case, it's a diary that's not really, I did this, but I found this. I found a link, and I found another link. And these lists, they're called awesome lists on the internet. For example, somebody really is into JavaScript and wants to develop it better and faster and more modern, less error prone or something. So they find links that help them, and they share those links, and other people contribute back other links and kick out older that are not so good anymore. And those are the lists that are maintained in Git. So that's not source code, but it's collaborating on version control files. Another example that's very exciting, I mean, for me it's exciting. I used to work a lot with spreadsheets, and I would have loved to have it back in the days. There's a company that makes it possible to use Git to version control your spreadsheets. Another thing that's probably the first thing that had been modified and tinkered with in collaborative manner is recipes, like real recipes. And here is actually a repository that tracks all kinds of taco recipes, and people contribute back their modifications, their enhancements, and that's really fun. For me, probably the weirdest case where I found that you can use Git for that is when somebody actually modified the law. And it's apparently in Washington, D.C., they publish their legal texts, and somebody found that there was a typo and changed the typo and published that, and then asked, could you merge that back? So just like I asked Jane before in that example to merge back my changes, they asked to merge that back. But by accepting that merge request, they actually accepted that into law, which is mind-blowing that you can contribute to real written law via Git. So if you're interested in weird use cases like this, or not so weird but fascinating use cases like this, there is a regular newsletter that you can subscribe to. It's called Git Rev News. The website is git.github.io, and there you will find the link on this left side. It's quite technical because it's very centered on the Git project. And the Git project is actually run on a mailing list. It's not run on GitHub. It's really a mailing list where everything is sent and discussed. And this is just basically trying to coalesce the most important developments and then giving you a couple of links at the end. If you're not so much into the technical details of C programming, you might be better off following the GitHub blog, which has a really excellent summary of pretty much every new version that comes out of Git. So the most recent one is 2.26.2, but the major version was 2.26.0. The .1 and .2 only fixed security bugs. And so the major features that came into 2.26 were described in a way that's much better than I could ever do on the GitHub blog. With that, I would like to go back to Git for Windows. Whoops, there, right. Git for Windows is actually in Git speak a fork, which means we did not only diverge with the idea to get merged back, but we diverged with the idea of, yeah, this will be maintained in of its own, but we try to contribute back our patches. So basically, the first premise is we want to make Git work well, very well on Windows. And so we have a couple of patches that try to make that happen. And sometimes we also have bug fixes that seem like they should fix things, and we get them, we take them into Git for Windows first, and then we have them for a couple of versions. And once those versions stabilize, the patch stabilizes, then we contribute it back to what we call the upstream Git project. And Git for Windows is actually developed on GitHub. It's we try to discuss everything in pull requests on GitHub or in the bug tracker, in the issues, and in the future we'll probably use the new discussion feature because that's basically open source lives on GitHub, right? When I say Git for Windows is developed there, of course, I should also mention that we really, really try very hard not to make this only for Windows. So we have patches on top of Git, but we also try to ensure all the time that this works well also on Mac and on Linux. We tried so hard, in fact, that Microsoft, which has its own fork of Git for Windows actually, so it's a fork of a fork. So they stack their patches on top of Git for Windows patches, and they release with every of their new versions not only the Windows installer here, the exe, not only the package, which is the macOS package, but also a Debian package, which is a Linux package. So it is compiled and built for Linux. Now, just for a moment, savor the idea of Microsoft publishing something that targets Linux. As I said, 10 years ago, I could not have imagined that. Times are changing. So with that, let me go back to the history a little bit, because a lot of the decisions and the design and the problems really of Git can be understood only if you keep in mind where it comes from. And it comes from the Linux kernel development. In fact, in 2005, Linus Torvalds, the maintainer of the Linux kernel, wrote this and collaborated with other Linux kernel developers in order to cater to the needs of the Linux kernel development pretty much exclusively. And those people are really used to the command line. Those people really love the idea of the Unix concept of having small programs that do one thing and one thing well, and then coupling them together and batch scripts, or Unix shell scripts, they're called. And that's how it really, really looked like. Back in 2005, in order to make a commit, what you did was to run git write-tree, and it gave you the cryptic string back that describes that tree. And then you said, with that tree, git commit-tree, and then also said, this is the parent commit, or the parent commits by hand. And then you typed a commit message into that command, and then you hit return and Control D, and then it created that commit. So that was very super low level, that thinking. And that informs still on a couple of designs how you have to do things in Git. We're trying to fix those one by one. I come to a couple of those later, describing how we are trying to reduce the reliance on shell scripting. Now, between 2005 and 2007, if you wanted to use Git on Windows, you had to use a project called Cygwin. Cygwin is a really fantastic program. They try to give you a very Linux-like environment on Windows. And in order to make that happen, what they use is a Cygwin runtime. It's a POSIX emulation layer. So all those functions that you take for granted when you're developing on Linux or Unix that are not there on Windows, they provide in that emulation layer. That comes with a price. I mean, the benefit is clear. You can basically take your source code that works on Linux to build software, and you almost don't have to change it. Sometimes you have to change a little bit here or there, but it usually works on Cygwin without any changes. But it's slow. At times it's even as slow as 100 times slower than native Windows code. And that's just because of that emulation layer, because emulation takes time. So in 2006, when I started work at a company, it was just a freelancing job for a couple of months, and they wanted me to work on Windows. Their entire fleet of computers was only Windows. Back in those days, I really didn't like to work on Windows. And I didn't like the slowness of Cygwin. So I spent some time to make Git work better natively on Windows. But before I was finished, my gig at that company was over. And so I posted my patches to the Git mailing list and said, look, here's some stuff that I've done. It's not complete, but if you want to go ahead and enhance it further, be my guest. And unbeknownst to me, somebody jumped right into it and worked for some half year. So in spring 2007, another Johannes, that's always really funny, Johannes 6th. So the first letters are JS. So Johannes and Johannes basically did the initial Windows port of Git. He came back and said, yeah, here, those are my patches on top, and now it works. And somebody else came back to the Git mail and said, yeah, okay, so this works, but I don't know how to compile this. I don't know how to build this on Windows. And admittedly, it was very complex. You had to install something that's called MSys. It's a package management system that brings basically a toned down Cygwin. But it also brings MingW, which is a GNU C compiler that targets Windows without that POSIX emulation layer. So you can compile stuff that using that POSIX emulation layer, that build stuff won't use the emulation layer. And that's what we use to build Git. And I say, yeah, sure. The other Johannes was on vacation, so I provided a zip archive of all the things that you need, and then I also provided an installer, or something that I called an installer. It was a self-extracting executable archive. And yeah, basically I've been stuck with maintaining Git for Windows ever since. It has its good sides. I'm at a pretty sweet job right now, and I'm working in Microsoft since 2015, and do this maintenance as part of my full day job. I also use that opportunity to modernize the thing. It's no longer based on MSys, it's based on MSys 2, and it uses 64-bit executables for the most part. So for the 64-bit version, we can build 64-bit just because of that upgrade. It took quite a while to get there, and then it worked quite well. So what are the challenges after making it build on Windows? Well, the most important I showed you already. Command line. I think most Windows users will just run away if you tell them, oh, you just need to start the command prompt. It's just not their world. This is much better, right? So we bundle a couple of graphical user interfaces in Git for Windows, but more importantly, with Git for Windows, we also support other applications that target this, that allow you to use Git. For example, here, that's Team Explorer, that's included in Visual Studio. The line endings are a big issue because when you write text and on Windows, it usually has as line endings 2 bytes at the end of the line that indicate now go back to the beginning of the line and then advance. And on Linux, it's just 1. And so we had to reconcile that somehow in the repository so that a version is recorded in the revision history that's compatible with Windows and with Unix or Linux or Mac or whatever else. There's also the problems of paths looking different. There's the problem that if you have files, the file names are not case sensitive on Windows. So if you write a file that's named hello, all lowercase, and then you open hello in all uppercase, that finds that file. Not on Linux, it doesn't. There are other things. Git for Windows is actually not just Git. On Linux, the Git package can just use the entire ecosystem of available packages. And we just need to provide all that. We actually provide 150, a conglomeration of 150 packages that are put into one Git for Windows installer. So for example, the secure shell is bundled, or there are several components that are necessary so that Git can talk to a website like GitHub via HTTPS. And if any of those components has a security hole and a fix for that, I need to release a new version of Git for Windows. The same is not true on Linux or Mac. They just that's an independently maintained package. Of course, that comes at a price. It comes at a price of, in the meantime, it's actually no longer 230 megabytes. In the meantime, it's more like 300 megabyte on disk. So we also provide a subset that's intended for applications. So all the interactive stuff is just missing from that, and also some integrations with other version control systems like Subversion, that's missing. And so the footprint is much, much smaller. So this was originally intended mainly for Visual Studio, and now it's also integrated into GitHub Desktop, the Atom editor, and I don't know what other applications also bundle this part to support Windows better. Now here, I also categorized a little bit what you need. So web libraries, those are the libraries that are necessary so that Git can talk to GitHub or GitLab or Bitbucket. And yeah, the build tools are really only needed for me as a maintainer and for contributors who want to enhance Git for Windows. Now the scripting environment is a little bit more crucial from the end user point of view. It's, as I said, the heritage of Git is Linux, where it's common to just script things. And those scripts in Git for Windows have to be executed via that POSIX emulation layer, so they're slow. Unfortunately, some core commands are scripted, and so they're super slow on Windows. So here is just a little overview, and those that are crossed out, we managed in the past few years to convert them from shell scripts to portable C code. And so the impact on the end user is, for example, Git rebase became 5 times faster right out of the box just because it's no longer scripted. 5 times. So instead of 5 minutes, you wait 1 minute. Still a minute, but a minute is, you can wait it out. 5 minutes, you go do another thing and then forget about the rebase and come back at the end of the day. So here are a couple of things that are, they're pretty technical, but it's behind the scenes. It's differences that we have to deal with, right? So the thing that we use in order to make all this possible to maintain Git for Windows properly, that's automation. So for example, when we make a new change, automated builds on Linux, on Windows, on Mac OS verify that this works there. And if we build a new new Git for Windows package, then that's an automated build. Then manual testing, and then publishing it is another automated build. I mean, it sounds like this is not a big thing, but we bundle 32-bit and 64-bit versions of the installer of portable Git, of the minute Git for applications. We publish NuGet packages, and all that has to be published to different sites. And then the Git for Windows SDK, so the development kit that we use to maintain and to allow contributors to contribute, also needs to be updated. That's all automated so that I don't have to spend much time. Just for comparison, before I started at Microsoft and started automating all this, it took me something like 5 days straight in order to get out a new release of Git for Windows. And now it takes me something like 3 hours in total. So that's a big change. Another thing is, if any of those components has a new version, those components that are bundled, then IFTTT, which is a cool service on the internet, will notify me of those. I install some triggers there. Then I trigger manually those builds that build those packages and update the Git for Windows SDK. So all those new versions come in. Another thing is, all those patches of Git for Windows that are on top of Git, when a new Git version comes out, we use an interactive rebase, which used to be a shell script, and now it's fully built into Git rebase. And it can rebase all those branches, which, I mean, it's a thicket of branches. It's not only just one branch. And all those are semi-automatically, within a minute, usually, rebased onto the new version. A little bit about, so I want to give you a little glimpse into what's coming next. The next talk by Stoli about scalar. Where that comes from is, if Git is for everyone, it's also for those developers who have insanely large repositories. And by insanely large, I mean insanely large. The repository is 300 gigabytes, and that's packed. And there are 3.5 million files in there, and all those have to be reconciled with a merge. So we worked quite heavily on that. And in the meantime, we're on a good track to get this into Git proper. So far, you need Microsoft's fork of Git, and you need a special server component. But we're getting there to get Git usable for everyone. With that, I would like to thank you for your attention and take your questions.